What happens as our consumer's decision becomes more complex? That is, how does Jim maximize his utility when faced with choosing among multiple products and having to worry about prices? Let's say that Jim stops off at the mall food court for some lunch, and for him, at this moment, the marginal utility of a slice of pizza would be 100 units of utility. The marginal utility of a small soda would be 50 units of utility. To maximize utility, which should Jim pick first? If he has no worries over income or price, he would choose the pizza. But the fact is that prices do matter. In this case, let's say that the pizza is $2.50 and the small soda is $1. If Jim considers how to get the most added satisfaction per dollar spent with each spending decision, then he will achieve the maximum possible utility when all of his income's been spent. So, which product yields greater added satisfaction, marginal utility, per dollar? If you take a look at the pizza, the marginal utility over the price is 100 utils, or units of satisfaction, divided by $2.50. The pizza yields 40 units of utility per dollar. The Coke gives 50 units of utility and costs $1, so it yields 50 units of utility per dollar. Coke wins this one. But hold on a minute. Once I buy the Coke, the marginal utility of Coke falls, and then what? Eventually, as the consumer continues the pattern of choosing the greatest marginal utility per dollar spent, an equilibrium will be reached. Consumer equilibrium occurs when the marginal utility per last dollar spent is equal across all goods and all income has been spent. Think about it this way. What if this isn't true? What if, say, product K gives more satisfaction per dollar than any other product? I'd do better to cut back elsewhere and buy more of product K. Similarly, if product W gives less marginal utility per dollar spent, you'd want to cut back on W until all were equal. Okay, look. Assume a consumer has a weekly income of $100, which he spends completely on 3 commodities: pizza, beer, and cigarettes. The price of pizza is $12, the price of beer is $8, and the price of cigarettes is $4. What combination of pizza, beer, and cigarettes is this consumer going to choose? Well, right now, there just isn't enough information to answer this question. It's not enough to know your consumer's budget. You also need to have information about his or her preferences. For example, if this were me, I don't drink or smoke, so I'd spend all of my money on pizza. This means we need some additional information about our hypothetical consumer. Remember when we went through the cookie activity? The utility figures reflected the consumer's tastes and preferences. I'm going to use the following table to determine our consumer's preferences. Notice that for each product, the law of diminishing marginal utility holds. And remember, our consumer has $100, price of pizza is $12, price of beer is $8, and the price of cigarettes is $4. Pretend for a moment that you are this consumer, and like all consumers, you're a utility maximizer. What would you choose first? The first pizza, the first beer, or the first cigarettes? It's easy to go astray on this one because the first pizza yields the greatest additional utility. The problem is that the 85 units of utility are also more expensive than the alternatives. To figure out where to get the biggest bang for your buck, we're going to have to calculate not just marginal utility, but marginal utility per dollar spent. This isn't too hard. All we need to do is divide each of the marginal utility figures by the price of that product. For example, that first pizza, yes, it yields 85 units of added utility, but those 85 units will cost you $12. That means that the first pizza really yields 7.08 units of utility per dollar. Is this the best you can do? No. Take a look at that first pack of cigarettes. Even though it has a lower added utility than either pizza or beer, it's also cheaper than the other products. Per dollar, the cigarettes yield more additional satisfaction. So the consumer's first choice is to buy the first pack of cigarettes. At $4, the consumer still has $96 left. What will he choose next? Now that the first pack of cigarettes has been consumed, the question is, will this consumer choose the first pizza, the first beer, or the second pack of cigarettes? At 12 units of utility per dollar, cigarettes still win out over the first pizza, 7.08 units of satisfaction per dollar, and the first beer, 8.75 units of satisfaction per dollar. So the consumer chooses the second pack of cigarettes, leaving him with $92. And so the process goes. The consumer chooses a third pack of cigarettes, leaving $88, and then switches to his first beer. Apparently he's thirsty after 3 packs of cigarettes. He still has $80 left, so he continues, going right back to cigarettes. Next is the second beer, then finally some food with the first pizza. Still having $56, our consumer keeps going. The third beer, the fifth cigarettes, then the second pizza, followed by the fourth beer. Now stop for a minute. What do you notice about the next choice? What would be the best option? The third pizza, the fifth beer, or the 6 cigarettes? They all yield 5 additional units of utility per dollar. Each of them would be an equally good choice. Coincidentally enough, our consumer has $24 remaining, exactly enough to purchase one more of each commodity with 0 leftover income. In the end, this consumer, given $100, will choose 3 pizzas, 5 beer, and 6 cigarettes for a total utility of 717 units of satisfaction. I can tell this by adding up the marginal utilities from the units consumed. If you take a look at the pizza, the first gave 85, the second gave 72, the third gave 60 for a total of 217 units of satisfaction from those 3 pizzas. You could calculate for the cigarettes and the beer as well. Overall total, 717 units. This consumer has achieved consumer equilibrium, where the marginal utility per last dollar spent for each good is equal. No other combination gives greater utility. Just to prove this to yourself, you could spend your $100 in either of the following ways, but what would your total utility be? Next time, indifference curves.